Hello guys, in this video we are going to talk about random forest. So random forest is a type of ensemble learning. In ensemble learning also there are two types, homogeneous ensemble and heterogeneous ensemble. So homogeneous means similar, ensemble means together. So there'll be a lot of models. So till now in the videos we have seen only one particular model. Now this particular random forest concept is like it is a mix of decision trees. So we used to learn only one particular model till now. Now we are going to mix one particular model, that is decision tree for this case, and using the mixture of decision trees we are going to arrive at a new model which is random forest. So it is something like it is a ensemble of many models. So if all the models are homogeneous, that is if all the models are same, all decision trees or something else, say all Bayesian classifiers, something like that, then it is called an homogeneous ensemble. Homogeneous means same, so everything is same sort of. And example is random forest. So random forest is like a ensemble of trees, decision trees. Similarly, we can have a heterogeneous ensemble. So in heterogeneous ensemble, we have a choice. We can take one perceptron, we can take a decision tree, we can take SVM. So we'll have an ensemble of many different models working together to serve one purpose. So here today we are going to see the random forest. So in my previous video you saw that decision trees have low bias and high variance. So even if you change little bit in the training data, so if a particular sample goes from here to here, it changes, then the model significantly changes. It significantly changes the decision tree model, right? So what we did, for random forest we have something that is called the concept of bagging. So what happens is, instead of using the whole training data at once on one decision tree, so suppose this is my a set of training data. It is having total n samples, this small n samples. So this is a set of training samples that I have, and what we can do is, using multiple versions of training set, each created by drawing n dash where n is less than n. So what we'll do is we will draw some samples randomly. So suppose I drew a sample like this and I made this as a subset. Now this will be my training set 1. Then I can have this as my suppose training set 2. So please note that I am allowing overlap. Your overlap is allowed. Then I can have this as my training set 3, training set 4, training set 5, training set 6, training set 7, then suppose training set 8. So like this I can have many numbers of training set depending upon how much accuracy I want. So I am dividing my complete training set into small training subsets, where I am allowing overlapping. Now what we will do is, with each of this new training subset, learn a decision tree. So for each subset you can learn a decision tree. So for this subset I will have a separate decision tree, for this subset I can have a separate decision tree, for a separate decision tree, and so on. So there will be something like this. There is a decision tree. Some decision tree over here. Then there is some other decision tree. So with all the subsets, I can make one decision tree. So in this case, I will get 8 decision trees. So in practice, random forest consists of a lot of decision trees. So the number can be as huge as suppose 100 trees. or it can be also 200 to 300 trees. It depends on the application. So now there are so many trees that we have. So you will have to learn all these trees. So if there are 100 trees, you'll have to learn all the 100 trees. So now that you can see that all the 100 trees have different sort of data. So because of that, um, the the structure of the decision trees may vary significantly because of this particular effect. A little change, so here there is a lot of change in the data, right? So because of this, what will happen is, after all the trees are learned, so the decision trees will have high variance in these trees, and they will be significantly different from each other because they have different training data, right? So after all the trees are learned, so if I learn all the 100 trees over here, what I'm going to do is, we are done with the training of random forest. So then the training is done. I just have to learn the different number of trees that I have. Now in order to test, now suppose I want to test a particular sample, so what I can do is put the least a test sample through all the decision trees and see the output of all the trees. So now I have a test sample somewhere. Now put this test sample in all the trees and see what is the output that each tree is generating. Suppose this tree says it belongs to class 1. This tree says it belongs to class 1. And there is other tree which says it belongs to class 2. So now what you can do is, you can go with the majority. Since the majority is saying class 1, so that may be right. So it is like this. It is like, um, initially you are just asking one person some questions. So because it was only one person, so he was giving his own subjective answer. But now what you are doing is, you are asking to a crowd. So when you are asking to a crowd, you can expect that the answer is more accurate, because a majority, it is like voting. So majority people are voting to a particular class, then that is more probable to be right. So that is the logic of random trees. And see the output of all trees and select the class which has majority of trees that are pointing to the class, a particular class. So like this over here. Also please note that don't get confused, this is a um, set of training data. So it is like, suppose this is my training data, training samples. So what I am doing is, I am arranging this in a particular way, such that I have these over here. So the three samples of and this is this set that I have over here. So this set consists of elements from both the class. So I've just taken all of them together, so that I could divide them in, so I can divide these also in subsets and so on. That is what I've done. So that's all for this video. Thank you so much for watching. Thank you.